Okay. The beginning of 4.2 asks us to prove using limits that the derivative of sine x is cosine x and that the derivative of cosine x is negative sine of x. We're not going to do that. I'm just going to write them. At the beginning, first the function for y equals sine of x, the derivative of y, dy by dx is cosine of x, and then for y equals cosine of x, its derivative function is negative the sine of x. So again, we could walk through a proof using the limits as h approaches 0, the first principle definition of derivatives in order to find it out, and the addition identity for sine. But we're not going to do that. We're going to skip right into the lesson, which is basically just using the rules for derivatives in finding the derivatives of sine and cosine functions. So, for example 1, we're dealing with the constant multiple rule, which states that the derivative of any function that has a constant multiple out in front of it, so any polynomial or any rational function that is multiplied by a constant, the derivative of that to find the derivative of that, you can just put the constant out in front. So the derivative of a function multiplied by a constant is the same as the derivative of that function multiplied by the constant. Constant multiple rule.
Did we skip for part 1?
So our first effort here, y equals 2 times the sine of x. Well, what are we going to do? We're going to take the derivative of, what should I do here? So the derivative of y then is the derivative of 2 times the sine of x. Okay, so you can see we have a function, sine of x, and it has a constant multiplier of 2. So what we can do then is just put that 2 out in front and take the derivative of sine of x. We know that the derivative of sine of x is cosine of x. So the derivative here is just 2 times the cosine of x, and that is done. This is the constant multiple rule. Second one, B, we are given f of x equals negative 3 times the cosine of x. Again, I'm going to write every step. You really wouldn't have to write every step. I mean, in your practice problems, you probably would just right away go to negative 3 times negative the sine of x, because that's the derivative of this function, and you have that negative 3 out front, and then you'd have positive 3 sine of x, which is what we would get to. And yeah, I guess we can just skip right down to that. So we've got the derivative of f of x. Our constant stays out in front, and we just take the derivative of the given function. which is negative the sine of x. Simplify 3 times the sine of x. Again, constant multiple rule. Example 2. Example 2, we apply sum and difference rules. Just as a note before we begin, they state that if you have, so sum and difference rules, I'm just going to write what they wrote and then we'll talk about it. Okay, so if you need to find the derivative of a function that is a sum of two functions, then what are we doing? So that's this. If we're taking the derivative of a function that is the sum of two functions, where both functions are differentiable, that's the same as taking the derivative of the first function and adding it to the derivative of the second function. If you have a difference function, so where your function is the difference between two other functions, then you're just taking the first function and subtracting the derivative of the second function. So what does that mean? You don't need to write this, but let's say you had something like 2x plus the sine of x, and you wanted to take the derivative of that. Well, that would just be the same. Taking the derivative of the whole thing is the same as taking the derivative of this part and adding it to the derivative of this part. Okay, pretty straightforward. So let's look at the ones that they do give us to do.
But like, if you add for the first one, do you add for the second too, or subtract for the second?
Add. So if the first one's adding, the second one is adding. If the first one is subtraction, the second one is subtraction. Yeah. Yeah, if you want to write this two separate things, one with addition and one with rewrite their same sentence with subtraction, you can do that if that helps. So the first one, y equals the sine of x plus the cosine of x. And we want to find the derivative of that. We want to find dy by dx. All we need to do is take the derivative of our first function. The derivative of sine x is cosine x. And we're still adding. We're going to take the derivative of cosine x, which is negative sine x, and simplify. We get cos x minus sine x. This is apply the sum rule. Example 2b, we're given y equals 2 cos x minus 4 sine x. So I see I have two functions. It's the difference of two functions. So I'm going to use my difference rule. And I see within each function we have a constant multiplier, constant multiple law. So dy by dx, I leave this 2 out front and multiply it by the derivative of cosine of x, which is negative the sine of x. I'm going to leave that negative sign, negative 4 times the derivative of sine x, which is cos x, and reduce. This is negative 2 sine x minus 4 cosine of x. This was difference rule and constant multiple rule. Example 3. We deal with the slope at a point. So now we're dealing with a sinusoidal function. So it's going to be a curve. And we want to find the slope of the tangent line at a specific point. So first I'm gonna draw, you can see what is there. Maybe I'll write down the function that we're working with is f of x equals 3 times the sine of x. And we're looking for the slope at the point where x equals pi over 4. Just to think about this for a second, if I draw a bit of a sinusoidal wave, that's pretty terrible, but and it has an amplitude of 3. So we have a max of 3 and a min of -3. And just to get our heads back in the world of sinusoidal functions, we haven't stretched or compressed it horizontally. So it takes one full period length will be 2 pi. Here's 4 pi. Half a period length will be pi, right? 180 degrees is pi. Here you've got pi over 2. And here is pi over 4. So basically what we're saying is we're looking for the slope of the tangent line approximately here. Yeah? Okay. So what we need to do first then is differentiate the function with respect to x. So f prime of x is 3 times the cosine of x. The value of the derivative at our point with x value pi over 4 will give the slope of the tangent at that point. Okay, so all we have to do here then is sub in pi over 4, 3 times the cosine of pi over 4. And of course we have all those values memorized. Maybe I'll hand out our unit circle again. But the cosine of pi over 4, does anybody actually have it memorized?
Is square root of 2 over something, I think.
Yeah.
1 over square root. Okay.
Yeah, square root of 2 over 2 or 1 over radical 2. And we multiply that by 3, we can simplify that to 3 over radical 2. So this is the slope of the tangent at pi over 4. Okay? Let's write that. So the slope of the tangent at x equals pi over 4 is 3 over radical 2. Just to write that another way, slope of the tangent, that is the instantaneous rate of change. Example 4, equation of a tangent line. So we're going to take our last example, the concept there, and take it a little bit further, which means we're also going to get the tangent point. So then we'll have the point and the slope, and we'll be able to get an equation for the tangent line. The function that is given is f of x equals -2 times the sine of x, and we want the equation of the tangent where x equals pi over 6. If we drew a quick sketch of this thing, looks something like this, and we're looking for, here's pi over 2, so our tangent is somewhere in here, pi over 6, minimum of -2, positive of, maximum of positive 2. Okay, so we're looking for a fairly steep negative tangent. All right, let's see how we do. Step one, you could go either way. You could first find the tangent point, so the value that corresponds with an x of pi over 6. Or you could differentiate this first to find the slope at that point. We'll find the tangent point first. Tangent point. All that means is we're going to sub in our x value of pi over 6 into our equation for f of x. So we're finding f of pi over 6 equals -2 times the sine of pi over 6. Sine of pi over 6 is 1/2. So we have -2 times 1/2, which is -1. So the point that we're going through here is pi over 6, -1. Now, slope. To find the slope, we're taking the first derivative of our function. So we're going to find f prime of x, which is a constant multiple law, times the cosine of x, which is the derivative of sine of x. And now we need to find the slope at our tangent point. So all we have to do is into our first derivative, sub pi over 6, -2 times the cosine of pi over 6. The cosine of pi over 6 is radical 3 over 2. Our 2's cancel out, and we're left with negative radical 3. All right, so the slope at this point is negative radical 3. And from there, we can get our equation using point slope form, which is y minus y1 equals m times x minus x1. Sub in what we know. We've got y minus -1, which is the y value of our tangent point, equals the slope, which is negative radical 3 times x minus x1, which is the x coordinate of our tangent point, pi over 6. And now we just work on simplifying this. So I'm going to remember to add, this is y plus 1, so I'm going to remember to subtract 1 from the right side at the end once I'm done distributing. We have negative radical 3 times x plus radical 3 pi over 6 minus 1. And this is then the equation of our tangent line at the point where x equals pi over 6. We wouldn't, if we want an exact line, an exact equation, we would not simplify this. Okay, if you only need to approximate, then you would probably group all of that. This is just a number. There's no variables in here. It's just a number. So if you needed to just approximate, then you would put those together. But I think we'll mostly be leaving them as exact answers. Okay, any questions on that one? It's nothing super new, other than this looks a little bit awkward. I'll get you your unit circle so that you can figure out your special angles, the cosine and sine of special angles more easily. Okay, practice problems that you should be able to do for 4.2 come from page 225. It's looking like numbers 1 through 13.